What's up, y'all? So today I decided to show you guys my code for a project that I did on what went wrong for the Raiders in their playoff game against the Bengals in this past postseason. I'll link that video in the description. It's also my first video on the channel. In that video, I discussed a lot of the data and why I personally disagreed with the decision that the Raiders made that I believe was costly and really hurt their chances at winning or at least continuing the game. I was able to access that data with nflfastR in RStudio. So with nflfastR in RStudio, I decided to show you guys my code and my processes to show how I was able to get all the data I wanted and how I was able to visualize the data as well. Yeah, so the first step obviously is to load or install all your libraries. You can install a library just simply using this install.packages command. For example, you can install tidyverse. I already have it installed. I already have my libraries downloaded as well. Simply just use this library command to get all your libraries. Library tidyverse, library nflfastR, and lastly, the last one we need is ggimage. ggimage. Awesome. Okay. So now we have our libraries downloaded. We can use nflfastR and start getting into the data. With that being said, all you need to do is use this built-in function nflfastR. You can use the load PVP function to load the play-by-play data for any year or multiple years at a time. You can use this colon to do all the play-by-play data from 2012 to 2011. You can also use this names command to find all the variables within nflfastR. You could just do this. I think they're about 372, sorry. Yeah, but you can see all the variables, expected points, touchdown probability, no score probability, field goal probability, quarterback spike, play type, shotgun, quarterback kneel. These are kind of bit characteristics where it's a yes or no, 0 or 1, down, drive, goal to go. It has everything that you could ask for. So obviously the next step is to create our data frame, which I titled data. As you can see, it's already here. That you can just simply do data, use this little arrow, load play-by-play 2021. The next step, obviously, or it's not obvious, but the next step would be to filter the season type equal to the postseason. Something also important to note is the double equal signs. I haven't really covered that before, but for tidyverse you need double equal signs rather than just the equal sign because it will get confused. I want to filter the season type equal to the postseason rather than the regular season. I also want to filter the possessing team to be the Las Vegas Raiders. I want to filter the defensive team equal to the Cincinnati Bengals. And lastly, I only want the data that was in the fourth quarter. Well, that's not all I want, actually. I also want to find data based on the time remaining, which you can obviously use with game seconds remaining. If I wanted to do it that way, I could do game seconds remaining. I wanted to filter the data only to be, well, you could actually equal less than or equal to 45 and game seconds remaining greater than or equal to 25. Now, I didn't want to do this because I didn't realize that you could just find the time remaining. I honestly thought it was a lot more complicated because I just saw time, which I'll show you how it works in a bit. If you just want to see how time works, you could just do data, use the pipe, and select time. So as you can see, time is a character rather than a number, which is hard to evaluate, so R is confused and doesn't really understand what this means as in 6 minutes and 41 seconds. It just sees it as a character and just some numbers. Yeah, and if you wanted to see something that would be numerical, you can just select something like the quarter, and as you see, it's a numerical trait. So time and quarter are both different, but you want to shorten the time. So if you wanted to like filter the time, well, you can't have the select command here, sorry, but if you wanted to filter like time is less than 1, it has no idea what you mean. So it's just going to show you all the data. And as you can see, there are 28 observations, so you only have 26 observations in this sequence. So obviously it thinks that it means a 1 in the ones place. If you want to see it here, it just takes out these 2 observations when, you know, if you wanted to filter time less than 1, you'd probably want it to be less than 1 minute, but R gets pretty confused. So what I wanted to show you guys is how I found the amount of time remaining using this character, because I didn't notice that you could just use the game seconds remaining that is right here. Regardless, yeah, here's the next step. So you want to use a separate command, which is similar to a substring command in SQL. You want to separate time, and you could use a C, which is basically like a column, and you can make a column for minute and second, and now that you're separating time, what do you think is going to be the minutes? This will be the minutes, that will be the seconds, and here's what what becomes from the separating data. This is what you're separating, and this is also really important, but this is where you're splitting the data from, or where you're separating from, and these 372 variables is going to change pretty quickly into 373, because now you have 2 new variables in minutes and seconds. So the next step is, if you wanted to look at the 2 of them, data, select minute, second, oops, and boom. Now you have the minutes remaining and the seconds remaining. But here's the issue, they're both still characters, but you know, obviously they're numbers. Is there a way that we can fix that? Turns out there is. If it applies, you can just do this, data, and now we can use a mutate command, which could just mutate a column. You could do minute equals mean, which wouldn't really make sense, but you could do that. But for our purposes, we want to use this other command, and it's an as numeric command. And we could just change the data type from a character to a number, and we could do that both for minutes and seconds. And boom. And now you're thinking, oh, maybe did it change? We could just use this same command, and boom, now they're number characteristics instead of characters. Yeah, so obviously the next step could be, ooh, I messed up. Yeah, so yeah, I did mess it up. That's why it looks the same, because I did that. But now I kind of messed everything up, so I have to just redo all this code. Boom, it's going to change. Boom, 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 boom. Yeah, so the issue I had was I used minute, so it got confused. Also, when I used the separate command, it deleted time. So if I tried to do this, data select time, it's going to get confused because time doesn't exist. But yeah, so I messed it up by having minute here, so it just mutated 2 columns with that name as minute and second. But obviously you don't really have minutes, so I wanted to find how much time was remaining in seconds. So you could just do data. You want to create another data set where you mutate data minutes into seconds, which you can simply just do seconds in minutes. That's what I titled it in my code. Minutes equal to minute, which I already created, as you can see up here, but the second in minutes will just be that times 60, and the next step after that, well, you'll just see you get a new column, and that's seconds and minutes, and the next step would be to mutate that again to find the total amount of seconds remaining by just adding the seconds and minutes with the seconds. So you could just do seconds remaining equal to seconds in minutes plus second, which obviously is kind of confusing because it probably could be seconds instead. But here we have it, and boom, 375 variables. So with that being said, now we can shorten the variables to see what we want. That sounded confusing, sorry, but we can shrink the data set to only get the data that we want. So we can just do data. Again, we already have these filters, and now we have this new seconds remaining command, and we could just filter seconds remaining is greater than or equal to 45, and we could use this ampersand to have 2 commands in the same filter command, and seconds remaining is less than or equal to 25. Oops. Yeah, I messed up both of these. Greater than and is less than. But now we are all in good shape, and boom. And now we only have 4 observations, so they're going to shrink our data so that we have only 4 plays to look at. So my next step was I just wanted to get familiar with what was going on in the data set, and I wanted to just see what was going on. So I just wanted to use a simple select command. I just wanted to select the possessing team, which will be the Raiders. And as you can see, all the variables will show up here. Time, win probability, score, timeouts remaining, everything. Yeah, score, differential. I also wanted to look at seconds remaining, that column that I created. I also wanted to look at some numerical values, such as the down, yard line, expected points added on that play, win probability added, touchdown probability, you know, as you can see it pop up, and no score probability. Now I'm going to run this, and boom, you see all this show up. This was the first play that I wanted to look at. It was a 3rd and 10 at the Bengals 19-yard line. You could see the likelihood that the Raiders had to win the game or continue it at least. It was pretty low, and then it went shooting up, and then it started to go down. So what I wanted to look at was the 3rd and 10, where they got a first down, then the 1st and 10, or the 1st and 9 at the, and 1st and goal at the 9-yard line, where they purposely threw an incompletion. They spiked the ball on purpose. So their expected points was about 3. It went up about 1.5 points after that first down. Their win probability went up almost 8%. Their touchdown probability almost doubled. Their no score probability went down by 10%. And their chances were still pretty low, but it wasn't stacked against them. And then they spiked the ball, and that's where I was just really disappointed in their decision making, because they sacrificed half an expected point, they sacrificed 3% of win probability, they sacrificed 10% of touchdown probability, which is huge because they need a touchdown to continue or try to win the game, and they're more likely not to score, which isn't as important, but it's still something that I believe is pretty important. So now my goal here is to plot the data. So my next step here is just to join the data with a built-in nflfastR function called teams colors logos. You can just do a simple left join. It's going to show up teams colors logos as I said before, and I want to do it by possessing team is equal to team abbreviation, which is what it is in teams colors logo, so that you could join the data by the same team logo. And if you just run this, boom. Sorry. Yeah, that the equal signs are kind of confusing, but I messed up. I didn't even mean to include the double equal signs, but yeah, that's why it's kind of confusing. Here in this scenario, you don't need double equal signs. Same thing for mutate. Yeah, you don't need it in that scenario. You need it for the filter command, but you don't need it for things like joins, mutates. When you're plotting stuff, you don't need it either. So yeah, now let's get into plotting the data with teams, colors, and logos. So now that I have my data set, I could just do data, ggplot, and we can use aesthetics. And we want to set up the X and Y axis. I'll just simply do win probability right now. I want to set X equal to, let's just do game seconds remaining because we have that now. And we can set the Y equal to win probability. Now that we have the team's colors logos, we could just use geom image, again aesthetics, and set the image equal to team logo ESPN. This you need Wi-Fi for. I'm sure you probably will have Wi-Fi, but you also need Wi-Fi. And you can just use this other command, geom line, so that you will continue following the data as you go along with it, point by point. So you have a point here and then a line connecting every point to the next point. And lastly, I like to label my graphs. You could just use this labs command and set the x-axis equal to whatever you want. So seconds remaining. You could set the y-axis equal to win probability instead of WP. And you can title the graph whatever you want. So win probability and seconds remaining. And you could also create a caption such as, why did the Raiders do this? And you could just run that code and boom. You have the logo here. I believe it starts here. Yeah. You can see my caption, you can see the title, you can see the columns. It might look kind of yucky here because usually you read left to right. So in my original code, what I did was this. I don't really need this caption here. Yeah, I just did negative seconds remaining. It doesn't really confuse the eye. And as you can see, the win probability is pretty low. After that one play, it shoots up almost 23%, and then it goes boom right back down under 20%, which I personally I found that super interesting. And something else you can do with the data is you could try to neaten up the text. Something that I try to do is use this theme command, and we can set plot.title equal to element text. So we could set the text equal to whatever we want. We could set the size equal to 400. I usually use 12. We can set the face equal to bold if we want to make it pop out more. And something that I find is a lot more important is we could just set the horizontal adjustment equal to 0.5, so it'll be centered, and it'll just look a lot neater. And you'll see, boom, that nice little bold title here. Oh, yeah, I messed it up. I forgot to use this, and now it will show up. Also, something important to note is when you're in ggplot, you're going to need to use addition symbols instead of the normal pipe that's used for tidyverse. That's for ggplot. If you use the pipe, ggplot will get confused and it won't actually pass the code through. But as you can see, the title is nice and centered. You have your nice X and Y axes, and yeah, you have everything. You could also just copy the same data plots for expected points, touchdown probability, and I also did one for no score probability. You could just simply slightly change the aesthetics for the y-axis as well as your caption, or not your caption, your y and x-axis labels, expected points, expected points and seconds remaining. You'll get a whole new graph, whole new title. It will probably look similar because expected points and win probability are super similar usually. Yeah, you can, sorry, I didn't need to write that out. You could also just do the same thing with something like touchdown probability. This will probably look a little bit different because the numbers are a lot higher for touchdown probability, where it's, it could be 50%, where win probability is pretty low in that scenario for the Raiders at least. And let's just plot this last one. Probably spelled that wrong, but it is whatever. And as you can see, it still looks the same because after that one play, boom, their odds shot up. It was super high, and then they spiked the ball on purpose, which, why did they do that? Maybe they thought that it'd be more helpful for the team. Obviously, it wasn't. Obviously, they lost, and hindsight's 2020, but didn't really make that much sense to do, as you saw with expected points, win probability, and touchdown probability. I could also plot it for no score probability, which will look different. I won't change the caption here, it's not that important, and it will just look, boom. The odds they wouldn't score were pretty high after the first down. The odds they wouldn't score went a little bit lower by, 10%, and then it went right back up after the spike. So by spiking the ball, they chose to be less likely to score. They chose to be less likely to get a touchdown. They chose to sacrifice about half of an expected point, and they sacrificed 3% of win probability. So obviously, hindsight's 2020, but I personally didn't like the decision very much. I'd love to talk about it in the comments if you want to discuss or talk about spikes in general. It's something I'm pretty interested in. But yeah, that should be it for the video. I covered filter, separate, mutate. I feel like that's all pretty important to understand, select, and just get a feel for the data set. You could just see the specific details you want. This was huge for me to understand what I wanted to look at, and when I saw what I wanted to capitalize on knowing, the expected points, the win probability, the touchdown probability, which I thought was super important on these 3 occurrences. I can see here it almost doubles and it goes down 10%, which is, in my opinion, really important. And then I figured out, I wanted to plot this. I wanted to plot it with the logo, which I, joined the data here, and I figured I wanted to add something like a line so you could follow the data where the win probability is pretty high and then it goes down. This is obviously no score probability, where the no score probability is high and it goes down. And if you want to look at something like touchdown probability, it starts off pretty low and it shoots up immediately, and then after the spike, which was on purpose, it goes right back down. That's it for the video. Thank you all so much for watching. I really appreciate it. I'd love to discuss. Please leave a like, please comment, subscribe. It'd be awesome. I'll try to make similar content to this. Yeah, thanks for watching. Please like, comment, subscribe, share it. That would be awesome. Yeah, thanks.